I'd like to start with a really brief overview of what Interledger is, what the problem is that we're trying to solve, and how we're addressing this so that it gives you some context, but don't worry too much about understanding every detail because this is something you're going to cover with Alan later in the week. Where I'd like to start is with the status quo. What is the problem that we have right now? Right now, financial institutions are very siloed. They all have their own different internal systems, which makes sending money and communicating directly between these financial institutions very difficult. So right now, you can either solve that problem by going through intermediaries, which increases costs and delays, or every time you want one institution to be able to communicate directly with another, they require custom integration because they do not have the same systems. And so they have to figure out how to bring their two different systems together. And this is very costly, time-consuming, and prone to errors. This is where Interledger comes in. Interledger is trying to create a standard way for these different institutions to communicate with each other. Interledger's goal is to make it as easy to send money as it is to send an email. And this means breaking down barriers so that anyone, anywhere can send money quickly, easily, and across currencies. Okay, it's an open protocol for seamless value transfer. When I say value, it's just because we didn't want to limit ourselves to only talking about money. It could be something like gift cards or units of work done. But I mean, for all intents and purposes of this talk, you can just think about it being an open protocol for how you can transfer money between different financial institutions. And Interledger is giving us a scalable, secure solution to interoperability. Okay, so if we have a look at that diagram I have, the column on the left to start off with, this is my depiction of the current problem that we have where we do not have a standard for interoperability. So a bank has its own proprietary systems, as does the digital wallet, as does the crypto wallet. If they want to be able to make transactions between them, the bank needs to talk to the digital wallet and they need to figure out what language they can speak that they both understand, how they can bring their two different systems together, what kinds of information are they sending to each other, how do they secure those messages, what is included in those messages, etc. And this is an exponential problem because now the digital wallet has to do that to talk to the crypto wallet. And if the bank wants to talk to the crypto wallet, they have to do that work again because everyone has a different system going on inside. And what standardization allows us is the scenario, that column on the right, where if we have one language, which is Interledger, and everyone is able to speak Interledger, they only have to do the work of integrating that language once, and they can speak to anyone on the system. So it takes an exponential problem and makes it a much more achievable problem because it is a once-off problem to solve. Okay, so just in case this hasn't quite landed, let's think of two really quick, simple examples. For instance, if we have countries that have different languages trying to do business with each other, so if there is a country that only speaks French and a country that only speaks Mandarin and they need to do business with each other, they can come up with another language, for example, English. And as long as everyone kind of ends up doing business in English, that means that instead of needing to create a whole new custom language that can bridge between Mandarin and French, which, as you can imagine, would be a really big task, they can just use one language that is commonly understood. And that makes communicating much, much simpler. So that's what Interledger is. It's this common language that if everyone can speak it, everyone only needs to learn this one language and they can speak to anyone on the system. Another example of how this is used in the world already is with email. So it doesn't matter when I send an email, if I have a Gmail account and you have an Outlook account, it really doesn't matter to me, because my email server, Gmail, already knows how to speak a common language that Outlook can understand. All right. So imagine if with an email, you could only send messages. If you are on Gmail, you could only send messages to someone else who also had a Gmail account, how limiting that would be. And that's kind of how the world of finance still looks today, is that we have real problems just sending money from one person to another if they're on different systems. Okay. And we want to solve that problem. So Interledger provides the standard for integrations. It's open, which means that anyone can use it. It's public, you know. It means that there's no more need to keep reinventing the wheel, and this alone reduces costs because it means that there's one solution. It's already been figured out. If you just integrate that, it opens up the world. Okay, so it also means that we minimize the needs for intermediaries because now if the bank wanted to talk directly to the crypto wallet, they wouldn't need to do so via the digital wallet because they already speak the same language. They can just cut out the middleman. And this can also lead to lowering of costs and also removing some delays. So when I talk about Interledger, what we have is actually a protocol suite. Okay, so there are a bunch of smaller protocols that make up the stack in a layered architecture approach. So each layer has a delegated responsibility. It knows how to communicate with the layers above it and below it. This is also, it means that we are standardizing the communication between layers. So that means that you can have more flexibility where you can interchange one layer with another. So for instance, you can use SPSP or you can use open payments. And it doesn't actually matter because Interledger speaks, both of them will be able to communicate directly with Stream. Right, so that gives flexibility. It also allows for more modular design, which is great for scalable solutions because as long as you are changing something inside of Stream, it doesn't really matter because as long as those communication lines remain intact, that means that the work done inside of it doesn't have to affect the layers above it or below it. Okay, so there's three main components that you need to understand when we're talking about Interledger, and that is ledgers, connectors, and packets. Okay, so ledgers are the systems that keep track of value. So think of bank account or blockchain, all right? Connectors are intermediaries that route payments from one ledger to another. Sometimes payments will go directly from a sender to a receiver, but other times they go through these intermediary connectors, okay? And packets are the units of data that carry this payment information through the network. So typically, a single payment would be broken up into smaller payment packets, and these packets are secured with execution conditions, so they can't be lost or stolen by intermediary connectors. Okay, so let's kind of look at the bottom little diagram I have there, and this is a cross-currency example. So, you know, when I said sometimes cutting out intermediaries reduces delays and costs, there are other times where intermediaries are actually adding value to the system. So if we think of a cross-currency example where a sender wants to send US dollars and a receiver wants to receive rands, and your institution only has dollars and my institution only has rands, then we need an intermediary who has both dollars and rands so that they can take the dollars and send on rands instead. Okay, and basically what we have here with these intermediaries is obviously they will then add on some kind of transaction fee to get something out of this, and they'll have to apply exchange rates and things like that. Okay, so in order to make this kind of communication seamless, because this is what Interledger wants to do, we want to say, I'm sending dollars, but I actually don't care what my recipient wants to receive this value in. If they want rands, great, you know, it shouldn't concern me. And Interledger is trying to solve these problems to make this more simple. So a lot of the layers in the protocol are dealing with questions like, how do we communicate with other connectors on the network? You know, how do we speak the same language and understand each other? How do we ensure that this communication is secure? How do connectors know, like, does the sender actually have sufficient funds to be making this payment? Connectors need to be able to adjust the amount so that they can include their transaction fees or handle exchange rates. We have a lot of routing questions that need to be answered, like if a connector gets a payment packet, how does it know where to send that packet next? How does it know what is the cheapest path to take through the network? And also, we want to make sure that payments never get tied up endlessly wandering through the network, because then your payment would be stuck in a pending state definitely and tie up your liquidity. So we need to make sure as well that payment packets expire. And if they expire, that simply means that that money that was being held in your account is released again and then payment failed. Okay. These are the kinds of problems Interledger is solving. Note that the bottom layer is our settlement layer, and this actually is outside of the Interledger protocol suite. This is where the actual transfer of funds is taking place between ledgers, and Interledger relies on pre-existing payment rails. So that's what banks, peer-to-peer payment schemes are implementing, ACH, blockchain, mobile money institutions, whatever. All right. Let's talk a little bit again on a lofty level about how Interledger is actually adding value to our ecosystem. And we want to make it easy and quick to send cross-border payments, to make cross-currency payments. And the big goal that we have is to increase financial inclusion. So not everyone has access to bank account. Not everyone has access to digital finance. And in cases where they do, we want to actually give people also access to better digital finance. You know, right now, for instance, a lot of people don't have enough money or infrastructure to have good banking experience or to have bank accounts. And there are scenarios where people are using digital wallets and they can only send money to other people who are on the same digital wallets. And that's a real challenge when perhaps someone is working overseas and would like to send money home to their family. And these are some of the big problems that we want to address, which is why we also care about these cross-border payments, cross-currency payments, financial inclusion. The other thing to realize with financial inclusion is that at the moment, transaction fees hit people the highest who are making small transactions, because proportionally, transaction fees are much higher when the amount being sent is not that big. And this means that people who are sending the smaller payments are actually getting hit harder, and that is excluding them as well from our financial system. So what Interledger is saying is that we are currency agnostic. We do not care what currency you're sending in. We don't care how much you send. We want to standardize the overhead of a transaction so that the same amount of work needs to be done, whether that transaction is really small or really large. And we have spoken about a couple of the ways about how we would like to create a system that can lead to reductions in these transaction fees. So we've spoken about how standardization reduces the cost of custom integrations. I've spoken about how minimizing the need for unnecessary intermediaries can lower costs and delays. The other thing, like I said, intermediaries aren't always bad. There are times when intermediaries enable cross-currency transfers to take place because they have both of the underlying currencies to actually handle the settlement of that transaction. But also intermediaries can add redundancy into a network. So for instance, if one of the connectors is down, they are having technical difficulties, or they've been shut down for legal reasons, or whatever the case may be, if there are other options in the network, it makes the network as a whole stronger. But another thing that this does is it allows for competition. So right now, you know, if your bank has a way of doing foreign exchange, they have that one way, they've set it up, you have to use it, you know. Whereas if we have a network where there are a bunch of different options offering foreign exchange, it means that you're going to choose the option that's the cheapest. And as soon as you have that kind of competition, it can also mean people end up lowering their fees to something that's perhaps a little bit more reasonable. Then there's another really cool use case, which I'm going to brush over here. We might be able to touch on it later, we'll see. But this is the idea of streaming micropayments. So if it's as much work to send a small payment as a large payment, and that's actually the overhead of that has been reduced and standardized, it enables a use case where we're able to stream over the internet these really tiny payments. I'm talking fractions of a cent. And what that opens up is, you know, if you think right now you go onto the web, you're either being bombarded by ads, and this comes with, I mean, first of all, it's just really annoying, but it also comes with privacy concerns and data mining concerns, right? And the other option, if you're not just getting ads, is that you have to sign up for a subscription, which again is annoying because every time you want to sign up for a subscription to a different site, you have to go through the whole process, enter your card details, set up a recurring payment, blah, blah, blah. And not to mention, these costs add up very quickly, because if I'm going to sign up for a subscription to the New York Times and I'm also going to get a Netflix subscription, they become really pricey, and that in itself is also prohibitive. So we want to imagine a world where you enter your payment details once and your browser is able to say, well, while you're on the site, you get to pay for what you're using while you're using it by having your browser send these really, really small payments every, let's say, second or couple of seconds or minute or whatever to someone on the other side of that website, so that you're paying directly for what you're using while you're using it. So if you're listening to music as it's being streamed, you are paying while you're listening. And I think that's a really cool use case that could revolutionize many things, one of which is how we experience the internet content. So we are here today to talk about this layer at the top, which is the application layer, open payments. Okay, so it's a standard for user-facing applications. That means something like e-commerce websites, or if you have a fundraising website, it's where people can make donations. Or if you have a streaming service, it's where people can pay for content, whatever it is, okay? This protocol here, Open Payments, is dealing with questions like account discovery. So where should money be sent exactly? And amount negotiations, like is it okay if these are the transaction fees? You never want to surprise a user with like how much they actually ended up spending. You always want to get that consent up front. You want to be transparent about it, how much is going to the bank, how much is going to the person you're paying, etc. Okay, it deals with questions like what transport protocol are we going to use? Are we going to use Stream? Stream has these concepts of shared secrets. So what shared secret should we use? And also optionally any other information that should be included in that payment packet data, like use this invoice identifier to credit the payment to your video subscription, or whatever the case is. Okay, that was a lot to cover. You don't have to understand all of it. The things I would like you to take away from this section is that financial systems right now are isolated, which means that you're relying on intermediaries or custom integrations, which are very costly. All right, standardization makes interoperability easier. Interoperability has a lot of benefits, from digital financial inclusion to revolutionizing digital financial experiences with things like streaming micropayments, which we call web monetization. Also, just a reminder that Interledger relies on existing payment rails. It has a layered architecture approach. And what's really great about that is that it means that we can use open payments on top of all of this without knowing exactly how everything underneath it works anyway.